Hello. So in this video, we're going to continue our exploration of the Asymptote vector programming language. And this time we're going to look at the data types in Asymptote that make it suitable for, graphics, vector graphics programming, which are a little peculiar. So before we go further, I just wanted to show you something which happens in conventional programming languages like C and Python, for example. If you just do 0.1 plus 0.2, you will find that you get something like 0.300004, which is actually not equal to 0.3. So this is because of the floating point, arithmetic not being consistent with decimal arithmetic. So that's just something to keep in mind. So now let's just start Asymptote by typing ASY. So this is like a REPL, read eval print loop, where you can actually type some expressions. For example, I'll type 1, it gives me 1, 3.14 gives me 3.14, 4 times 5.23 gives me 20.92. So this is reasonably consistent with any other programming language. You can also do something like this: int x is equal to 10 and then x, so int is one data type, real r is equal to 3.14 and r real is another data type, and you can basically create variables in this manner. This is fine. You can multiply reals and you can multiply reals and integers. You can also do some things like 0.5 into 10, and here is where I wanted to just show you that 0.1 plus 0.2 will actually give you 0.3, and Asymptote is a little more forgiving in terms of arithmetic. Okay, but it seems so, but you should just be very, very careful. Okay, so if you don't believe me, you can just do this, you will get that. Okay, so just be aware when you do floating point arithmetic, it's a printing related thing that you just don't fall for it. Okay, what are the other interesting data types for Asymptote for a vector graphics language? So there are two interesting data types I'll show you. One is called pair, and you can basically do something like this. Pair P1 is 0, 0. Pair P2 is something like, let's say 1, 1. Pair P3 is 2, 0. Okay, and you have three pairs. Pairs are basically pairs of real numbers, something like an x coordinate and y coordinate. We can actually try to draw some shape. Okay, let's do something like this. Okay, we'll say 5 size cm. Okay, and then we'll say draw P1 hyphen P2 dot P3. Okay, and that gives me this kind of shape. Okay, but I want the dot to kind of represent I want the dot to be a Bezier curve which goes to the right first. So I can just give the right vector, which is I can just say 1, 0, and then you will see that you get this shape. Of course, it doesn't flush the drawing, which is why you have an overlapping picture. So let's actually go to our editor and then just start doing this properly. Okay, so let me actually, you can ignore the plot on the right. Settings dot out format is PDF, and we'll choose our size as 5 cm, and then let's do our standard thing. We'll say pair P1 is equal to, and we'll say something like 0, 0. Pair P2 is something like 1, 1. And pair P3 is equal to 2, 0. Okay, and we'll say pair right. Okay, because we want to go, actually we don't need, right is already predefined. So let's continue. So now what you want to do is this: you want to basically say path. Okay, a path is basically a collection of pairs. Path, my path, is equal to P1 dot P2, and then you go to the right and dot P3. And we'll say draw my path, and then we'll say asymptote example 2. Okay, so you can see that, I basically did this. Sorry about this. Yeah, so you basically have a straight line and then a Bezier curve. We'll in fact close this by putting cycle over here. That actually brings it back to the first point, and you can see that you get a nice shape. Now, an advantage of storing paths like this is that paths are actually objects which can be reused and which can be operated on. I'll give you some quick examples. Let's just try to shift this path to the right. So we use 2 units over here. Okay, and we're just going to shift it to the right by 2 units. So we'll just do this: shift 2, 0, that is 2 units to the right, star my path. Star is a special operator here. It's not multiplication. It signifies an operation to be performed on my path. Okay, you can see that a copy of the path has been made to the right. If I make it 3, 0, you will find that there's 1 unit of separation. Yes, so that's basically one way. You can also rotate Okay, let's try to rotate this by about 90 degrees. But remember, default rotation is about 0, 0. So that's why it goes to the top and you get some shape which is like this. But we want to rotate it over there. So, let's remove this rotate temporarily. And I want to rotate it about this particular point over here. That point is 3, 0. So what I'm going to say is rotate 90, 3, 0. Oops, sorry. I should close this bracket. And there you have it. It has rotated by 90 degrees. Okay. So now this leads to an interesting example. What we can do is we can actually draw a couple of equilateral triangles and then try to make a shape out of them. So something like this is what we are aiming for. So we're going to say settings.out format is PDF, size 5 cm. Now let's first draw this equilateral triangle. To draw this equilateral triangle, I'm going to say path my triangle is equal to, and I'm going to go from 0, 0 to, so for equilateral triangle of side 1, I should go to cos pi by 3, sin pi by 3, I guess. Okay. And finally, I will go to, I think I should go to 1, 0. And then we just draw this to check whether we get my triangle. Oh yeah, I should build this one. Okay, I get a nice triangle. Now I want to rotate this triangle and then bring it, and rotate this triangle and then just overlap on top of it. So I'm going to say path reverse triangle is rotate 180 star my triangle. And then I'm going to draw reverse triangle and let's see what happens. Remember, the default rotation is about 0, 0. So it has rotated it about 0, 0 over here and brought it by 180 degrees, which is not what we want. We want to rotate it on this, from with the basis as the centroid, the axis as the centroid. So for the centroid of this particular equilateral triangle, if you remember your geometry, it's going to be half and root 3 by half of root 3 by 2. So I'm going to say SQRT 3 upon 4 and let's just do this. So if I do this, right, I get this kind of shape. So it has basically just drawn it on top of each other. I want to shift it below by about 3 cm. So what I'm going to do is I'm going to shift this to by maybe I don't know how many, 0.3 units, minus 0 comma minus 0.3, and then we'll see what happens. Yeah, let me close this so that you get the cycle. There. Okay, you can play around with this particular number. Okay, this 0. You can make the 0.2 to get a slightly different effect. Okay, but you want it to be the same, so you have to just figure out the correct length by which you want to shift it down and you'll get it. I don't remember the exact length. I think it'll be close to 1/3, or if I'm not mistaken, you can verify, but you can make shapes like this. Before we close, I want to just comment about the units in Asymptote. So you can actually write convenient units, like you can write 1 cm, and 1 cm is actually 28.34 in the base units which Asymptote uses. You can actually do something like 1 pt, which is 0.99 points, and if you do 1 inch, you get the base as 72. So Asymptote roughly uses 72 dots per inch by default, and you have convenient units like mm, inch, and all those things. You can always just use any unit to scale the diagram appropriately and use it. So I'm going to add this code in the repository, which is in the description. So feel free to write your comments on whether you need some other doubts clarified. Happy to do so. Thank you.